If you were to jump up from the couch right now and start sprinting out the door for 15 seconds, the reactions that begin to occur in that short period of time to allow muscle contraction to occur involve the ATP-PCR system. This system is activated on the onset of exercise, which in this case you go from sitting to sprinting, and also the increase in intensity of exercise, which in this case you go from sedentary, not doing anything, to again a very high intensity of sprinting. This process is activated because there is a decrease in ATP and an increase in ADP. How that happens is in our bodies we begin with a level of 80 to 100 grams of ATP stored in our muscles for the onset of exercise. When we begin to sprint, this ATP is broken down so that our bodies can use it. So what happens is this ATP molecule is broken down through ATP PACE into ADP plus a phosphate plus some energy. Now, since we're breaking down these 80 to 100 grams of ATP, means we have a drastic increase in ADP in our cells. With this increase in ADP, it then activates the enzyme of CK. And CK, or creatine kinase, is used to break down PCR. When PCR is broken down through creatine kinase, it forms a free-floating creatine molecule as well as another free-floating phosphate molecule. Now, with all these free-floating phosphate molecules in our body, because of the breakdown of ATP and the breakdown of PCR, we now take one of those phosphate molecules that are free-floating plus an ADP molecule that was produced from the breakdown of, again, ATP, and we form an ATP molecule through the enzyme of ATP synthase. And again, while we're sprinting for these 15 seconds, we utilize this ATP first, but then once we are running out, the ATP PCR system keeps our ATP concentration from ever reaching zero, which is very important. And these several processes are occurring millions of times in all of our muscles throughout our body to allow us to sprint for those 15 seconds.